Brighton Beach, Brooklyn, August 1903. The afternoon sun hammered down on the wooden grandstands, packed tight with thousands of spectators clutching their hats against the wind coming off the Atlantic. They'd come to watch speed, pure, reckless, glorious speed, and nobody embodied that better than the 25-year-old Frenchman about to climb into the Packard Grey Wolf. Albert Champion, even his name sounded fast. He'd already conquered Europe on bicycles, winning the legendary Paris-Roubaix race in 1899, his legs churning through 250 kilometers of cobblestones and mud. 8 hours, 22 minutes. Champion by name, champion by nature. But bicycles weren't enough anymore. The internal combustion engine, now that was the future. The Grey Wolf's engine coughed to life, spitting blue smoke, and Albert Champion accelerated down the beach course. 50 miles per hour, 60. The crowd roared. But then something went wrong. The front wheel caught in a rut, and the entire machine pitched sideways. Champion flew through the air like a rag doll before slamming into the hard-packed sand with a sound that made people in the stands wince. His right leg shattered. Compound fracture of the femur, the kind of injury that in 1903 could easily kill you from infection. For months, Albert Champion lay in a hospital bed in France, his racing career over, one leg now 2 inches shorter than the other. He'd never run again, never race again. But lying there, staring at the ceiling, something else was happening in his mind. He'd spent years racing behind motorcycles in something called motor pacing, where cyclists drafted behind gas-powered bikes to reach incredible speeds. He knew engines, he knew electrical systems, and he knew they kept failing. See, the problem wasn't just Champion's problem, it was every engine's problem. And the problem was simple. Spark plugs were garbage. In 1903, if your automobile or motorcycle actually started, you were having a good day. Most mornings you'd crank and crank that engine until your arm felt like it might fall off, and nothing. Or maybe it'd fire once, sputter, and die. The culprit, 9 times out of 10, was the spark plug. Early designs used mica, this flaky mineral that was brittle as glass. Mica insulators would crack from engine heat, let moisture seep in, and short out the electrical current before it could jump the gap and ignite the fuel mixture. Some manufacturers tried steatite, basically soapstone, but that wasn't much better. A few desperate inventors even tried wood. Yes, wood, which tells you how bad things were. Porcelain was supposed to be the answer. This refined ceramic made from kaolin clay, the same stuff they used for fine china and laboratory equipment. It could handle high temperatures without melting, at least in theory. But here's the problem. Porcelain didn't expand and contract at the same rate as the metal parts around it. When an engine heated up to operating temperature, the metal expanded one way, the porcelain expanded a different way, and crack. The insulator would split right down the middle. Sometimes spectacularly, with a shower of white ceramic fragments shooting out of the engine. Back to square one. And this wasn't just inconvenient, this was strangling the entire automotive industry in its cradle. Henry Ford was trying to sell cars to regular people, not just wealthy tinkerers. But how do you sell a car that won't reliably start? Buick, Oldsmobile, Cadillac, all of them were buying spark plugs from whoever could make them, and most of those plugs lasted maybe a few hundred miles before they fouled or cracked or just mysteriously stopped working. The Raja company made plugs, so did dozens of other outfits, but none of them had solved the fundamental material science problem. How do you make an insulator that could withstand 4,500 degrees Fahrenheit, resist electrical leakage, handle thermal shock from cold starts, seal against 2,000 pounds per square inch of combustion pressure, and do all of this while being small enough to thread into a cylinder head? Albert Champion spent his recovery time in Paris visiting machine shops and electrical component factories. His friend, Edouard Nieuwpoort, ran a company making spark plugs and magnetos for the aviation and automotive industries. Champion studied their designs, took them apart, asked questions. Nieuwpoort's plugs used a better grade of porcelain than most, kiln-fired clay imported from specific deposits in France, where the kaolin was exceptionally pure. The process mattered. How you mix the clay, what temperature you fired it at, how long you let it cure. Champion learned all of it. He started sketching improvements, better electrode shielding, improved sealing, longer insulator nose to prevent fouling. By early 1908, Champion had designs he believed would actually work. But he had no money. Racing pays well when you win, but medical bills and months of recovery had drained his savings. He needed investors, he needed a factory, and he needed to get back to America where the automotive industry was exploding. In June of 1905, Albert Champion stepped off a ship in Boston Harbor, walking with a pronounced limp, carrying nothing but his sketches and a burning conviction that he could build a better spark plug than anyone in the world. Within weeks, he'd convinced two brothers, Robert and Frank Stranahan, to back him. The Stranahans dealt in imported auto parts. They knew the market, knew the desperation manufacturers felt for reliable ignition components. They put up the capital. Champion brought the knowledge. They rented space in the Cyclorama building in Boston's South End, this massive brick structure with a circular interior, originally built to display panoramic paintings of the Battle of Gettysburg. Not exactly where you'd expect the future of automotive technology to be born, but it had cheap rent and high ceilings. The Albert Champion Company officially opened for business, initially just importing electrical parts from France, Europort components, magnetos, switches, but Champion's real goal was manufacturing. By early 1907, he'd set up a kiln, arranged shipments of that special French clay, and started producing the first American-made spark plugs with true ceramic porcelain insulators. Not just any porcelain. This was kiln-fired at specific temperatures that created a denser, harder material than the cheap porcelain most companies used. The clay mixture included specific minerals that gave it better thermal properties. And the design protected the center electrode from grounding against the metal shell, kept moisture out better than anything on the market, and could actually survive the hellish environment inside an engine cylinder. The plugs had Champion stamped right on the side. Simple, confident, and they worked. Automobile manufacturers started buying them. Racers started winning with them. Word spread fast in the small, tight-knit automotive community. If you wanted your engine to start reliably, you bought Champion plugs. Orders started flowing. The company grew, more employees, bigger production. Robert Stranahan's younger brother Spencer joined the operation. By early 1908, the Albert Champion Company was manufacturing thousands of spark plugs a month. But there was a problem nobody had quite noticed yet. The company was called the Albert Champion Company. The plugs were called Champion. But Albert Champion? He didn't actually own the company. The Stranahans did. They'd put up the money, so they controlled the stock. Champion was an employee, a highly valued employee, sure, the technical genius behind the whole thing, but still, he worked for them. And increasingly, Albert Champion was realizing he had no real say in how his own designs were manufactured or sold. He was president in title. In practice, he was a very well-paid engineer with his name on someone else's product. And that was about to cause one of the most fascinating corporate battles in early automotive history, one that would lead to two competing spark plug companies, both founded by the same man, both bearing his name in different ways, and both destined to become giants of the industry. But we're getting ahead of ourselves. Summer of 1908, Boston. The tension in the Albert Champion Company had gone from uncomfortable to unbearable. Champion wanted to expand, wanted to experiment with new formulations, wanted to push the technology forward. The Stranahan brothers wanted profit margins and stable production. They were businessmen. He was an inventor. And those two types of people, they don't always see eye to eye. Some accounts say Champion left voluntarily. Others say the Stranahans forced him out. The truth probably lands somewhere in between. What's clear is this. By mid-1908, Albert Champion was done working for other people. Then fate intervened in the form of a chance meeting at a Boston Buick dealership. William Crapo Durant. If you know anything about the automotive industry, that name should make you sit up straight. Durant was the founder of Buick, and he was in the middle of building something even bigger, though Champion didn't know it yet. Durant had come to Boston for business, and somehow, through the small world network of early automobile men, he ended up meeting Champion. They got to talking. Durant mentioned Buick's constant headaches with spark plugs. The company was buying them from Raja, and the failure rate was embarrassing. Engines that wouldn't start, plugs that fouled after a few hundred miles, customer complaints stacking up. Champion showed Durant his prototypes. Better ceramic insulators, improved electrode design, sealing that actually worked. Durant was no engineer, but he understood numbers. He did the math. Buick was paying Raja for plugs that kept failing. If he could manufacture plugs in-house using Champion's superior design, he'd save money, improve reliability, and control his supply chain all at once. This wasn't just about spark plugs. This was about vertical integration. Within weeks, Durant had convinced Champion to move to Flint, Michigan. "Bring your wife, bring your brother, bring whoever you need," Durant said. "I'll set you up with a workshop inside the Buick factory. We'll call it the Champion Ignition Company. You make the plugs, Buick gets first dibs on everything you produce, and we'll supply other manufacturers too. You'll have creative control, you'll have resources, and you'll make a lot of money." Champion agreed. He packed up his life in Boston, gathered 11 employees who believed in him enough to follow him to Michigan, and in late summer of 1908, they arrived in Flint. 1 week, William Durant incorporated General Motors. Buick was the foundation. Then he bought Oldsmobile, then Cadillac, then what would become GMC Truck. And right there in the middle of it all, installed in Buick Factory Number 1, Albert Champion was making the spark plugs that would power Durant's automotive empire. Except there was a problem nobody had anticipated. Back in Boston, the Stranahan brothers were not happy. They still owned the Albert Champion Company. They still manufactured Champion spark plugs, and now their former employee, their former president, was in Michigan starting a new spark plug company using what they considered their designs, and more importantly, their name, the Champion name. They'd trademarked it, they owned it, and they were prepared to fight. The lawsuit landed like a bomb. The Stranahan brothers sued Albert Champion and the Champion Ignition Company in United States federal court, claiming trademark infringement and intellectual property theft. Their argument was simple. They'd been using the Champion name since 1905. They'd built a business around it. They'd spent money promoting it. You can't just walk away and start using the same name somewhere else. That's not how this works. Durant's lawyers fired back. The man's name is literally Albert Champion. He's not infringing on a trademark. He's using his own name. How can you trademark someone's actual identity? The case dragged on, and on, and on. Years turned into a decade. Legal briefs piled up. Depositions were taken. Both companies kept manufacturing spark plugs while lawyers battled in court. It was expensive, it was distracting, and it was getting uglier by the month. Meanwhile, in Flint, Champion was innovating. The ceramic insulators he developed in Boston were good, but he kept pushing them further. The challenge with ceramics is getting the thermal expansion coefficient right. Metal expands when heated at one rate. Ceramic expands at a different rate. If those rates don't match, you get stress fractures at the interface between the insulator and the metal shell. Champion experimented with different clay mixtures, different firing temperatures, different cooling rates. He brought in glass makers to help develop better glass seals between the center electrode and the ceramic. Each improvement was small, but cumulatively they added up to spark plugs that could survive longer, fire more reliably, and handle higher compression ratios as engines became more powerful. By 1010, even the early automotive racing scene was starting to notice. Champion plugs were showing up in winning cars at the Indianapolis Motor Speedway. Drivers trusted them, mechanics trusted them, and that reputation, that was worth more than any advertising campaign could buy. In Flint, the business was restructured as Alfred P. Sloan organized General Motors into distinct divisions. In 1916, Sloan made Champion Operation a freestanding division within GM, producing not just spark plugs but speedometers and other electrical components. They'd sell to GM brands, obviously, but also to outside manufacturers. The money started rolling in. By the early 1920s, the Flint operation was producing hundreds of thousands of spark plugs every month. But back to that lawsuit. By 1922, both sides were exhausted. 14 years of legal warfare, and neither side was winning decisively. So they settled, out of court. The terms were simple. The Stranahan brothers in Toledo would keep the Champion name and the Champion Spark Plug Company. Albert Champion's operation in Flint would have to change its name. It couldn't be called Champion anything anymore. So Champion did what made sense. He used his initials, AC. The company became AC Spark Plug Company. Clean, simple, different enough to avoid trademark issues. But everyone in the industry knew what those letters stood for. Albert Champion's plugs, made by the man himself. And here's where the story gets really interesting, because now you had two companies, both founded by the same person, both making ceramic insulated spark plugs, both competing for the same customers, and the competition would drive innovations that neither company would have developed on its own. The Stranahan brothers, now fully in control of the Champion spark plug company in Toledo, weren't sitting idle. By 1910, they'd been drowning in debt, nearly $20,000, which in 1910 money was equivalent to about $600,000 today. Then, Willys Overland Motor Company threw them a lifeline. Willys, one of the biggest automakers in the world at that time, offered them an exclusive contract to supply all their spark plugs, but only if Champion moved to Toledo, where Willys was headquartered. The Stranahans took the deal, moved the operation, and suddenly they were back in business. Then, a couple years later, they signed another exclusive contract with a small family-owned car company about an hour north of Toledo. Maybe you've heard of it. Ford Motor Company. By the time Henry Ford's Model T production was in full swing, the Stranahans were supplying millions of spark plugs a year. That $20,000 debt? Erased. The Stranahans became spectacularly wealthy. So now you've got Albert Champion's AC operation in Flint supplying General Motors and winning racing contracts, and you've got the Stranahan brothers' Champion operation in Toledo supplying Ford and Willys, both using ceramic porcelain insulators, both constantly improving their designs, both trying to out-engineer the other. But ceramics had limits. Porcelain was better than mica or steatite, sure, but it was still brittle. It could still crack. And as engines became more powerful through the 1920s, higher compression ratios, hotter running temperatures, more demanding conditions, even the best porcelain insulators were being pushed to their failure point. Champion needed something better, something stronger, something that could survive the punishment that high-performance engines were starting to dish out. And in 1921, they found it, in the most unlikely place imaginable. A mine in California, middle of nowhere, Inyo White Mountains, not too far from Death Valley, the Champion Mine. Yeah, seriously, that was its actual name. Pure coincidence. But inside that mine was a mineral called andalusite, chemical formula aluminum silicon oxide, Al2SiO5. By itself, andalusite wasn't particularly special, but when you heated it up to extremely high temperatures, something magical happened. The crystal structure rearranged itself. The andalusite transformed into a different mineral called sillimanite. Same chemical formula, but completely different properties. Sillimanite was harder than porcelain, stronger than porcelain, better thermal insulation, better electrical insulation. It could handle higher temperatures without degrading. And its thermal expansion coefficient, it was closer to metal than porcelain, which meant less stress, fewer cracks, longer life. When the Champion spark plug company started using Sillimanite insulators in 1921, the performance difference was immediate and dramatic. Spark plugs that used to last a few thousand miles were now lasting tens of thousands. Racing teams noticed first, then aviation. Sillimanite insulated spark plugs became the standard for any high-performance application. And here's where the beautiful part. The Champion Mine andalusite deposit was a one-of-a-kind deposit. Nobody else in the world had access to that material. Champion had stumbled into a natural monopoly. They owned the mine. They controlled the supply. If you wanted the best spark plug insulator material available, you had to buy Champion plugs, period. Every race car from the 1920s through the 1940s, Champion plugs. Almost every aircraft engine, Champion plugs. Barnstormers, airmail pilots, military training planes, they all used Champion because Sillimanite simply worked better than anything else available. Eventually, Champion opened a second andalusite mine near Lovelock, Nevada, just to keep up with demand. But they kept tight control, no selling raw Sillimanite to competitors. You wanted the material, you bought the finished plug. AC spark plug, meanwhile, had a problem. They were losing ground. General Motors was happy enough with their porcelain-insulated plugs for passenger cars, but racing teams and aviation customers, they were defecting to Champion en masse. Alfred P. Sloan himself was frustrated. Here was his company's spark plug division, bearing the founder's initials, being out-engineered by the founder's old company. The irony was thick enough to cut with a knife. But both companies were about to face a challenge neither of them had anticipated. October 27th, Paris, and a tragedy that would shock the automotive world. Paris, October 26, 1927. The Hotel Plaza Athene, evening. Albert Champion, now 49 years old, was in Paris with his second wife, Edna, a former chorus girl, attending an automobile show. By this point, Champion was wealthy, famous in automotive circles, and president of AC Sparkplug Company. Just a few months earlier, his plugs had gotten enormous publicity when Charles Lindbergh flew across the Atlantic with AC spark plugs in the spirit of St. Louis. That single flight had been worth more than any advertising campaign could buy. AC spark plugs, reliable enough to trust your life to over 3,000 miles of ocean. The orders were flooding in. That evening, Champion was at a banquet in his honor. Industry people, engineers, executives, the kind of event he'd attended 100 times. Except this time, something went wrong. According to witnesses, a man confronted Champion in the banquet room, a former prize fighter. There was a physical altercation. The man struck Champion hard. Whether it was one blow or several, accounts vary. What happened next is not in dispute. About an hour later, Albert Champion collapsed into a friend, dead. Cardiac arrest, or pulmonary embolism, depending on which medical account you believe. The Champion family later claimed Albert had caught the prize fighter with Edna. Others suggested it was more complicated. Whatever the truth, one thing was clear. The man who'd founded 2 spark plug companies, who'd revolutionized ceramic insulator technology, who'd put reliable ignition into millions of automobiles and aircraft, was gone. Just like that. In a hotel banquet room in Paris, the city where his racing career had started nearly 30 years earlier. General Motors immediately bought out Champion Estate and took full control of AC Sparkplug Company. The business didn't miss a beat. Production continued. Innovation continued. But the driving force, the restless mind always pushing for better materials and better designs, that was gone. Meanwhile, in Toledo, the Stranahan brothers were consolidating Champion Sparkplug Company's dominance. Their Sillimanite monopoly was printing money. But they weren't complacent. In 1931, Champion introduced something called a suppressor-type spark plug. This used a carbon-based resistor inside the plug to reduce radio interference. See, as radio became more common in automobiles through the 1930s, people started noticing that spark plugs created electrical noise that would make their radios hiss and crackle. The carbon resistor dampened that interference. Small innovation, but it mattered. It kept Champion ahead of the competition. But that competition was getting serious. AC Sparkplug, now fully owned by General Motors, had finally gotten tired of losing the high-performance market to Champion. And they had the resources of the largest corporation in the world backing them. So they went looking for an alternative to Sillimanite. In Germany, Siemens had been working on something called sintered alumina. This was pure aluminum oxide ceramic, not fired from clay, but sintered, heated and compressed from powdered alumina until it formed a dense, incredibly strong material. Siemens had developed it specifically to solve the spark plug insulator problem. Sintered alumina had thermal expansion almost identical to steel, 3 times the mechanical strength of Sillimanite, better electrical insulation, and it could be produced synthetically, no mining required, no limited natural deposits. If you could make alumina powder, which is easy, it's the intermediate product in aluminum smelting, produced by the millions of tons, you could make sintered alumina insulators. AC Sparkplug saw this technology and understood immediately what it meant. They licensed the process, set up production, and by the late 1930s were producing spark plugs with sintered alumina insulators that matched or exceeded Sillimanite performance, and they could make as many as they wanted. No supply constraint, no dependency on mines in California and Nevada. Champion Sparkplug saw the writing on the wall. Their material advantage was eroding. By the time World War II started in 1939, sintered alumina was clearly the future. But the war interrupted everything. Suddenly, spark plug production became a matter of national security. Aircraft engines, bombers, fighters, trainers, they all needed reliable ignition. Every plane had multiple engines. Every engine had multiple cylinders. Every cylinder needed at least one spark plug, sometimes 2.
and these were high-performance engines running at maximum power for hours at a time under combat conditions. Spark plug failures weren't just inconvenient, they could get people killed. Both Champion and AC ramped up production to levels that would have seemed impossible just a few years earlier. Champion's Sillimanite insulated plugs went into everything from P-51 Mustangs to B-17 Flying Fortresses. AC's sintered alumina plugs did the same. The military didn't care about brand rivalry. They needed plugs that worked, period. And both companies delivered. The war also accelerated development. Engineers learned to make sintered alumina insulators with increasingly precise properties. They optimized the thermal temperatures, the compression pressures, the grain structure of the ceramic. They developed better glass sealing techniques to bond the metal electrode to the ceramic without creating stress points. They figured out how to make the insulators self-cleaning at operating temperature, hot enough to burn off carbon deposits, but not so hot they'd cause pre-ignition. When the war ended in 1945, all that knowledge didn't just disappear, it got applied to civilian production. And immediately, sintered alumina replaced everything else. Mica, gone. Steatite, gone. Porcelain, mostly gone except for the cheapest applications. Even Sillimanite, Champion's secret weapon for 20-plus years, was obsolete overnight. Sintered alumina was simply better in every measurable way. Stronger, more reliable, longer lasting, and unlimited in supply. Champion spark plug adapted. They had to. They shifted their production over to sintered alumina. The Champion mine in California, which had been so valuable for 20-plus years, was no longer economically important. They shut it down. Today, it's a collector's site for mineral enthusiasts. You can still find Andalusite specimens there if you know where to look. But here's what's remarkable. Even though the material advantage was gone, both Champion and AC survived. They'd built reputations that went beyond just the insulator material. Champion had relationships with Ford, with racing teams, with aviation customers who'd been using their plugs since the 1920s. AC had the entire General Motors empire, plus outside sales to anyone who wanted plugs bearing the initials of the man who'd invented modern ceramic insulator technology. The 1950s and 60s saw constant refinement, better electrode materials, copper core center electrodes for improved heat dissipation, fine wire electrodes for more reliable sparking, extended nose insulators for engines with recessed plug wells, and always, always the sintered alumina insulator at the heart of it all. That ceramic material, developed in Germany, perfected in America during the war, became the standard that every spark plug manufacturer in the world used. Racing pushed the technology forward. Drag racers needed plugs that could survive nitromethane fuel burning at insane temperatures. NASCAR teams needed plugs that could last 500 miles at wide-open throttle. Aviation still needed absolute reliability. And increasingly, as emission controls became important in the 1970s, engineers needed spark plugs that could fire for 100,000 miles without degradation. Through all of it, Champion and AC competed, sometimes bitterly. They'd fight over racing sponsorships. They'd fight over OEM contracts with automakers. They'd fight over aftermarket shelf space in parts stores. But they also pushed each other to be better. Every time Champion introduced an innovation, AC had to match it or exceed it. Every time AC came out with something new, Champion had to respond. And all of it, traced back to a French bicycle racer who crashed on Brighton Beach in 1903, spent months recovering, and decided that the real future wasn't in racing cars, but in making the components that made those cars actually work. By the 1980s and 1990s, both companies were mature, global corporations. Champion had been bought by Federal Mogul. AC had become AC Delco, still part of General Motors. The spark plug market had gone from a wild west of dozens of competitors to a handful of major players. But the two biggest, the two oldest, the two with the deepest history, they both carried the legacy of the same man, one by his name, the other by his initials.
Let's talk about what makes sintered alumina special, because once you understand the material science, you understand why it became universal. Aluminum oxide, Al2O3, is one of the hardest materials you can make at industrial scale. On the Mohs hardness scale, it's a 9. Only diamond is harder. But hardness alone doesn't make a good spark plug insulator. You need the right combination of properties: electrical insulation, thermal conductivity, mechanical strength, resistance to thermal shock, and, this is critical, the right thermal expansion coefficient. The thermal expansion problem had plagued spark plug designers for decades. Picture this. You've got a steel shell, heated to maybe 600 or 700 degrees Fahrenheit during normal engine operation. Steel expands predictably when heated. Now, you've got a ceramic insulator inside that shell. If the ceramic expands at a different rate than the steel, you get stress at the interface. Not a little stress, enormous stress, enough to crack the ceramic or deform the metal. Either way, your seal fails, combustion gases leak out, and your spark plug dies. Porcelain expanded too little compared to steel. That's why early porcelain insulators cracked so often. The steel shell would expand, squeeze the porcelain, and crack. Sillimanite was better, but still not perfect. Sintered alumina, its thermal expansion coefficient was almost identical to steel. As the engine heated up, the metal and ceramic expanded together, no stress, no cracking. The plug could survive hundreds of thermal cycles from cold start to full operating temperature and back, without degradation. But making sintered alumina insulators wasn't simple. You started with alumina powder, pure aluminum oxide produced as an intermediate product during aluminum smelting using the Bayer process. That powder got mixed with small amounts of other materials, trade secrets, every manufacturer had their own formula, to control the sintering process. Then it was pressed into the rough shape of an insulator under enormous pressure, thousands of pounds per square inch. This compressed the powder into what's called a green form, fragile but holding its shape. Then came the firing, into a kiln at temperatures around 3,000 degrees Fahrenheit. At those temperatures, the alumina particles fused together at their boundaries without fully melting. That's sintering. The material densified, shrank slightly, became incredibly hard and strong. When it cooled, you had a white ceramic that looked like porcelain but was fundamentally different, stronger, denser, better in every way. After firing, the insulator had to be machined to final dimensions, ground on diamond wheels because regular cutting tools couldn't touch it. The center bore had to be perfectly straight and smooth. The outside had to be precisely dimensioned so it would fit into the metal shell with exact tolerances. The ribs on the outside, those distinctive ridges you see on every spark plug, those weren't just decorative. They increased the surface path length that electricity would have to travel from the terminal to the grounded shell. More distance meant better insulation. Then came the glazing. The fired insulator got dipped in a glass compound and fired again at lower temperature. This created a smooth, shiny surface that resisted carbon tracking and made the manufacturer's name and part numbers easy to print. That glossy white or cream-colored finish you see on spark plugs, that's the glaze. Finally, the metal parts. The center electrode, usually nickel alloy, had to be sealed into the ceramic insulator using special glass seals that would maintain integrity at high temperature. The metal shell, the hex nut portion that you grip with a wrench, threaded on the outside to screw into the engine, smooth bore on the inside to accept the ceramic insulator, the ground electrode, that metal tab that forms the spark gap, welded to the shell. All of it had to fit together with precise tolerances measured in thousandths of an inch. By the 1950s, both Champion and AC had refined this process to the point where they could produce millions of spark plugs a year with remarkably low defect rates. Quality control became critical. Every plug got tested, electrical resistance checked, spark gap measured, pressure tested to make sure the seals wouldn't leak. Only plugs that passed every test got packaged and shipped. And the competition kept driving innovation. In the 1960s, Champion introduced copper core center electrodes. Copper isn't a good electrode material by itself. It's too soft, would erode too quickly. But if you used a nickel alloy shell around a copper core, you got the best of both worlds. The nickel provided durability and electrical conductivity. The copper provided superior heat dissipation, pulling heat away from the electrode tip and transferring it to the shell and then to the engine cylinder head. This let engines run cooler plugs without fouling, or hotter plugs without pre-ignition, depending on the application. AC responded with their own copper core designs. Then both companies started experimenting with precious metals. Platinum electrode tips lasted longer than nickel because platinum didn't erode as fast under the constant electrical arc. Later came iridium, even harder and more resistant than platinum. These materials were expensive. Iridium was one of the rarest elements on Earth, but for high-end applications, the extended life was worth it.
The racing world became a testing ground. If a spark plug could survive an entire drag race on nitromethane fuel, where cylinder pressures and temperatures far exceeded anything in normal engines, it could survive anything. If it could last 500 miles at Daytona or Indianapolis, it could certainly last 50,000 miles in a grocery-getting sedan. Racing teams got free plugs. In return, the manufacturers got massive real-world testing under the most extreme conditions imaginable and massive publicity when their plugs were in winning cars. Champion was particularly aggressive in racing sponsorship. By the 1970s and 1980s, you couldn't watch a NASCAR or NHRA drag racing event without seeing Champion branding. Banners, uniforms, car decals. The message was clear. When winning matters, professionals choose Champion. AC, backed by General Motors, focused more on OEM contracts. If you bought a Chevrolet, Buick, Cadillac, Pontiac, Oldsmobile, it came with AC spark plugs from the factory. That's millions of plugs sold before the car even left the lot. But the 1970s brought a new challenge neither company had faced. The four emissions regulations. The Clean Air Act and subsequent EPA regulations meant engines had to burn cleaner. Catalytic converters became mandatory. Unleaded gasoline became the standard, and spark plugs had to adapt. Leaded gasoline had actually helped spark plugs in a weird way. The lead compounds created a protective coating on the electrodes that reduced erosion. With unleaded fuel, that protection was gone. Electrodes eroded faster. Spark plugs needed to be redesigned with materials that could survive longer without the lead buffer. This is when platinum and iridium really became important. The precious metals could survive 100,000 miles on unleaded fuel, where nickel electrodes might only last 30,000. The insulators themselves needed refinement too. Cleaner burning engines with catalytic converters ran hotter, and spark plugs had to survive those temperatures without degrading. Sintered alumina was already excellent, but manufacturers tweaked the formulations, slightly different grain sizes, different sintering temperatures, different additives to optimize performance for the new engines. Through all of this, the basic design remained remarkably consistent. Metal shell, ceramic insulator, center electrode, ground electrode, spark gap. The same fundamental architecture that Albert Champion had refined in 1907 was still being used 100 years later. The materials had improved dramatically. The manufacturing precision had increased by orders of magnitude. But the basic concept, protect an electrical conductor with ceramic so it can safely deliver high voltage into a hostile environment, that never changed.
Today, if you walk into an auto parts store and look at the spark plug section, you'll see Champion plugs. You'll see AC Delco plugs. Both brands, still competing, more than a century after Albert Champion made his first ceramic insulated plug in Boston. Federal Mogul bought Champion in the 1990s. Then Tenneco bought Federal Mogul. Then Apollo Global Management bought Tenneco. The brand has changed hands multiple times, but it still exists, still produces millions of plugs a year, still sponsors racing teams. You can still buy Champion spark plugs for everything from your lawnmower to your high-performance sports car. AC Delco remains part of General Motors, now branded as part of their parts and service division. They produce plugs not just for GM vehicles, but for the aftermarket. The initials AC still stand for what they always stood for: Albert Champion. The name lives on. And both companies still use sintered alumina insulators. That technology, developed in the 1930s, perfected during World War II, has remained the standard because nothing better has come along. Engineers have tried other materials, silicon nitride, boron nitride, zirconia-toughened alumina. Some of these materials have advantages in specific applications, but for general-purpose spark plugs, standard sintered alumina still hits the sweet spot of performance, cost, and manufacturability. The modern spark plug is a miracle of material science and precision manufacturing. That ceramic insulator has to survive conditions that would destroy most materials: 4,500 degrees Fahrenheit, 2,000 pounds of pressure, 18,000 volts of electricity, corrosive combustion gases, thermal cycling from below freezing to full operating temperature hundreds of times a week. And it has to do this for 50,000, 100,000, even 150,000 miles without failing. Think about that. You start your car in January when it's 10 degrees outside. The spark plug is frozen. You turn the key, 18,000 volts arc across that gap.
Boom, combustion. Within seconds, the plug tip is over 1,000 degrees. You drive to work, shut off the engine, the plug cools back down. Do that twice a day for 5 years. That plug is going to fire millions of times, survive millions of thermal cycles, and never miss a beat. That's what ceramic insulator technology, pioneered by Albert Champion over 100 years ago, makes possible. Aviation still relies on the same technology. Modern aircraft engines, whether piston engines in small planes or turbine igniter plugs in jets, use ceramic insulators descended directly from Champion's designs. The Space Shuttle used ceramic igniters for its rocket engines. The Apollo program used them. Every time you board a commercial airliner, ceramic spark plug technology is part of what's keeping you safe. But here's what's really remarkable about this story. One man founded 2 companies that would become bitter rivals. One man's name is on plugs made by a company that forced him out. His initials are on plugs made by the company he actually built. And both companies succeeded. Both survived the Depression, 2 world wars, the rise and fall of American manufacturing, globalization, corporate takeovers, and a century of technological change. That's not just business history. That's a story about how one person's obsession with solving a technical problem, a problem that everybody else thought was just how things were, changed the world. You turn your key, your engine starts. You probably never think about the spark plug. You shouldn't have to. That's the point. It should just work, every time, for years. That reliability, that taken-for-granted functionality, exists because Albert Champion refused to accept that spark plugs had to fail. He looked at the materials everyone else was using and said, there's got to be something better. He found ceramic. He refined it. He made it work. And we're still using it. The next time you start your car, take a second. Think about that little ceramic insulator down in your engine, surviving conditions that would melt steel, firing millions of times without complaint, never asking for attention, just doing its job. That's Champion's legacy. That's what one obsessed engineer gave to the world. 2 companies, 1 man, a century of innovation, and it all started with ceramic.